So what happens with inverse trigonometric functions? The trigonometric functions we have seen, of course, they are periodic. Okay, we have the sine of x, right? Which is not going to pass the horizontal line test. We have the cosine, which is also not going to pass the test. And neither the tangent is going to pass. Okay, the tangent is a little different. It has asymptotes, right? And then it repeats. All right. So this is pi over 2, negative pi over 2. Anyway, here we could think, well, that's it. There's no chance. They are not going to pass the horizontal line test. There's no inverse. Okay, so these functions, they have an inverse if we restrict their domains. Okay. What do I mean? So we need to restrict the domains to, here the first one was the sine, the second one was the cosine, and then the tangent. So what I mean is just to take a window that allows us to just pass once for every point. So for example, we are going to take this window for the cosine. Then for the sine, we are going to take this window. Okay, and then for the tangent, we are going to take this window. Okay, when we are looking inside these windows, the functions are going to pass the horizontal line test. So what are these windows? We need to write that down carefully. So the case of the inverse of the sine, and we usually write arc sine of x. Okay, this means the arc, the angle whose sine is x. Remember in the trigonometric circle? So if you have a sine that is x, you are asking about the angle. That is the arc sine of x. Okay, this is a radius 1. Sometimes you will see it written as sine to the minus 1 of x. This means the inverse of the sine. Sometimes I see this every year. Someone writes 1 over sine of x. This is absolutely wrong. Okay, and it messes up the problem. So be very clear that when you write sine minus 1 of x, that means the inverse. And if you want to express 1 over the sine, then you're going to write sine of x to the power minus 1, okay? But these are different. This is a different story. So let's take it out of the way. So how do we define this arc sine? So we need to focus on that window that I drew here, right? This window goes from the minimum that you find at negative pi over 2 to the maximum pi over 2. Okay, so in this case, we take as a domain negative 1, 1. Okay, and the range is going to be negative pi over 2, pi over 2. Okay, these are the domain and the range of the inverse. Now, when I look at the arc cosine, okay, whoops. The cosine to the negative 1 of x. When I look at this one, then what is the range and what is the domain? Just a comment. So when we have the unit circle, then here, this is my my x, okay, the cosine, and then the arc cosine is that angle. So in this case, the domain is again negative 1, 1. That didn't look good. Domain is negative 1, 1. Okay, and in this case, the range is going to be 0 to pi. Okay, why 0 to pi? Let's copy the picture we drew before. We could say, why don't you take negative pi to pi the same way we had for the sine? Well, that one will not work, you see, because if I go from negative pi to pi, then there is repetition of values because the cosine is even. Okay, so for this to work, I need to start from 0 and then go all the way to pi. Even if it's the same length, if I don't do like this, it's not going to work. Okay, for example, if I take the window here, right, you see that I'm repeating points. This one and this one. So this window doesn't work. This window does work. So remember, from 0 to pi. Once in a while, it's very important that we remember exactly what's the range of the arcsine and the arccosine. And then when I look at the arctangent, right, which sometimes we write tangent to the -1 of x. I prefer the arctangent notation, but you see tangent to the -1 in some books. So I want you to be used to both of them. In this case, we have the tangent, and the domain is going to be negative infinity to infinity, and the range is going to be negative pi over 2 to pi over 2. Notice that I'm not including pi over 2 or negative pi over 2 because there is an asymptote. So the tangent never really, the arctangent never really gets there, okay? Let me show you. So when we apply the trick that we saw, that we just need to reflect respect to the line y equals x. Okay, we see that the arctangent is going to look something like this. Okay, and it's going to have two horizontal asymptotes. At y equals pi over 2 and y equals negative pi over 2. That means that the function never reaches those values, but approaches asymptotically to them. Okay. So remember, we need to restrict the domains of the trigonometric functions so we can invert. And they have slightly different ranges. Okay, the arcsine goes from negative pi over 2 to pi over 2, cosine from 0 to pi, and then the arctangent goes from negative pi over 2 to pi over 2. One more thing, I want to make this more explicit. When I say that they have a horizontal asymptote, what I mean is when I take the limit as x tends to infinity of the arctangent of x, that's going to be pi over 2, and the limit as x tends to negative infinity of the arctangent of x, that is going to be negative pi over 2. Okay, this is something we need to keep in mind, because once in a while there is a limit in the problems that says basically this, and I see all types of answers like 0, infinity, negative infinity, 1, does not exist. So remember, it's a horizontal asymptote, so limit as x tends to infinity, pi over 2, x tends to negative infinity, negative pi over 2. Let us graph carefully the arc sine and the arc cosine. So let's say I have y that is the sine of x. Okay, here we have it. And then let's graph y equals x. That will give us the reflection line. And then let's add y equals the arc sine of x. So you see it here that it's from negative pi over 2 to pi over 2, and it's perfectly reflected with respect to y equals x. Okay, similarly, we could be doing the cosine. The cosine of x. And then the arc cosine. Again here, we see the reflection of the piece that goes from 0 to pi. Okay, you see that if you reflect the piece of the cosine that goes from 0 to pi, respect to the y over x, what you get is what is displayed here in gray. Okay, that is the arc cosine. And then the arc tangent, this one we already did a rough sketch, but let's get something nice. The arc tangent, so the tangent is going to look like this, and the arc tangent is going to look like this. Okay, so we see here multiple branches from the arc tangent, but then the one that crosses 0 is the one that we are actually reflecting across y equals x. Now, one thing we need to be very careful about are the cancellations. Careful with cancellations, because sometimes it may be very tempting. For example, let's say that, that we have the arc sine of the sine of 2 pi. And we see the arc sine and the sine, and we say, okay, 2 pi. But here we have a problem, because when we go to the arc sine, we said that the range was negative pi over 2 to pi over 2. So here 2 pi is out of range. Okay, so this can't be. Okay, so we need to bring it back to the proper range. So how do we do this? Well, first, arc sine of the sine of 2 pi, the sine of 2 pi is going to be 0. Okay, and once we have the arc sine of 0, then we send it back to the proper value in the range, negative pi over 2 to pi over 2, then it's 0. Okay, so first you apply the sine, then you apply the arc cosine, then there is never any problem. Okay, another example could be to simplify the tangent of the arc cosine of x. Okay, let's say, what is this going to be? So for this, we need to look into the trigonometric circle. Okay. And say, well, if I have an angle, remember always the radius is equal to 1. If I have an angle such that the cosine is x, okay, what is going to be the tangent for this angle? So then you know, okay, the tangent is the sine of theta divided by the cosine of theta. This is the definition. This here, you know, this is the sine of theta, and the cosine is x. Okay, so we can apply the Pythagorean theorem. and say, well, the sine square of theta plus the cosine square of theta equals 1. This here is x squared. So then the sine of theta is the square root of 1 minus x squared. So then the tangent is going to be 1 minus x squared divided by x. And because theta was the arc cosine of x, then we are done. So the tangent of the arc cosine of x is given by the formula 1 minus x squared divided by x.